All right, now we're gonna start on some actual. This is still in the realm of algebra two, but it's kind of where we make the transition to pre-calculus. Okay, we're gonna talk about graphing functions and the toolkit functions, and that's what you're gonna get to play with this weekend. So just to introduce that, let's say that y equals x squared. We want to find y for each of the following x values. Now, people did very well on this. A couple little glitches, but everybody's going to understand it. So I demonstrated how I want you to write this out. If x equals 2, then you put the number for y here, and then you explain over here how you got the result. Okay? So I think we have a comment. I hope I didn't make a mistake on that calc. Okay. Something. Recording. Appreciate it. Okay. So anyhow, this is how we do it. So the rest of it's very straightforward. I'm going to do it quickly because everybody got almost all of it right. Most people got it all right. Okay. So we have, what's the result? Well, we don't know until we calculate it. And I'm going to give you some more numbers that involve a little bit more of the rules for exponents and stuff. So, the first thing you want to do is calculate it, but leave yourself room here to write the result. Don't make yourself look all the way over here for the result. Make sense? So you just have a table here. You could ignore the rest of this stuff, but you're just documenting in case something turns out wrong, in case something doesn't fit the pattern that's going to emerge. You're going to want to be able to look over here and review how you calculate it and say, oh, dang, I added instead of multiplied or whatever. Okay. So if you do that, you got to write 4 squared equals 4 times 4 equals 16. And you got to put 16 right here. So we can see what the numbers are without having to look all the way over. Okay. Okay. For -3. But he messed up the sign. In a pre-calculus class, a third of the class are going to tell me it's -9. If we do this like on the first day, third of the class will think that's -9. Another third will think it's -6, going to think, yeah. Okay. So right now, you're ahead of most people starting pre-calculus, at least on this, and I think on a lot of other stuff. Now, don't let that go to your head because most people start pre-calculus, get out of it within a couple of weeks. And then half the ones that don't get out of it a little later, okay? Because they don't have a mathematical background. And we're just starting to develop a good mathematical background for pre-calculus. You're getting the nuts and bolts of how to do the algebra and a little bit of other stuff. I'm just saying that if you do go on to pre-calculus, you want to do it along with the support course. Okay. 60% to 80% of the people who start pre-calculus really need that support course, even though they think they don't. So you're learning some stuff, and most of you are doing very well, but don't let it go to your head. Follow all the steps. Okay. Okay, anyhow. End of digression. That's 9. 1/2. 1/2 squared is 1/2 times 1/2, which is 1 times 1 over 2 times 2, which is 1 over 4. And I would like to see you write 1 times 1 over 2 times 2. Now that equal sign almost looks like a couple of negatives there. Just to make it a little clearer. That's written kind of small. Probably can't even see the dots. Make it a little clearer. And this is a dot, not a minus sign. Okay, so that's what we have. So next to 1/2 on this table, we're going to write 1/4. I threw in 2/3. That's 2/3 makes 2/3. If you take the time to write 2 times 2 over 3 times 3, you're going to be less likely in the future to not multiply your numerators and your denominators. Okay? This reinforces that you multiply the numerators and denominators. I recommend that you write that out. So that's 4/9. And then 1 squared equals 1 times 1, which is 1. And we have this, okay? Now we could graph these numbers. We'll put X here. I'm going to put Y here. Now you might or might not be familiar with how to graph ordered pairs. So I'm going to give you, I think, a quick and sufficient explanation. Now I'm going to go to the biggest positive number here, which is 4. Okay, my X values don't go past 4. If X is 4, Y equals 16. This dotted line here, I declare to be the line where X equals 4. Okay, for any point on this line, we say its X coordinate is 4 because it's directly above or below 4 units on the X axis. Okay. I'm going to modify this a little bit because we got a pretty big number there with 16. I'm going to go all the way up to here, and I'm going to say that on this line, everywhere on this line, Y is 16. That makes sense? So if you're on the X-axis, X is 4 right here. And X is 4 everywhere above and below this point on the X-axis. I can extend that line a little bit. And Y is 16 at every point on this dotted line. So X is 4 and Y is 16 with these two lines intersect. Okay. Now what I have is an X-axis moving to the right with an arrow on the end of it, a Y-axis, a vertical Y-axis with an arrow on top of it, and they cross at a point where X equals 0 and Y equals 0. So let me just write that. Here's where X equals 0. Everywhere on this line, which we call the Y-axis, make a statement. X equals 0 at every point. The axis. And then Y equals 0 at every point of the X-axis. Does all that make sense? Now, Open Maths is going to explain it to you in the traditional way, which is a little different, but completely compatible. If you understand what I'm doing here, you'll understand what they're doing there. If you know what they are doing, and many of you maybe already do, then you know what I'm doing. Okay. I prefer to scale my axes like this. Reason being that if X equals 4, that's 4 units, right? Well, 4 units here, if I use the same scale, 4, 8, 12, 16. Y equals 16 would have to be up here if my scales were equal. You understand what I mean? If distances on the X-axis are measured the same as distances on the Y-axis, Y equals 16 ought to be a lot higher, or a little higher anyway. Okay? That doesn't matter because sometimes, let's say you're wanting to graph the value of an investment of $1,000, okay, over a period of 30 years. So you got to have numbers going to 1,000 here. Numbers only have to go up to 30 here. You're not going to use the same scale. Okay. 1,000 is over 30 times 30. So if 30 is out here, then 1,000 is about 25 feet in the air. Okay. So you won't always have equal scales. You adjust the scale to what you need. The scales you're going to see in open math are pretty much all equal scales, which is very restrictive, but it's not a bad way to start learning. Okay. I don't object to it, but from the beginning, I tell you, the scales don't have to be the same. Okay, so anyhow, this point where x equals 4 and y equals 16 represents that y is 2, y is 4, x equals 4. Okay, on the line x equals 4, which is a vertical line, and the line y equals 16 represents the fact that y is 16 when x equals 4. There's a point of it. Make sense? Now we can make the rest of the points. I'll make one more, and then I'll ask you to sketch likewise the rest of the points as best you can. Okay? And you're probably not going to be, if you haven't done a lot of graphing, you're probably not going to be great at it. But you have the right idea, and we'll talk about how to adjust it, make it more realistic. Now, your x scale has to be consistent. So if x is 4 here, then 4 units over here, x is -4 would be here. Now, I don't need that line, but it helps me stay honest. Okay. Now, if x is -4 here, then where is x equal to -3? Tell me. I'm going to move the chalk from here to the left. And I'm going to do this without looking at this because I want to look at you. Raise a finger or hand or throw something hard at me and let me know when you think I'm at x equals 3, -3. Fair enough? Let's go. Here we go. Okay. Anybody think I should move further? Anybody think I moved too far? Well, if that's x, well, you know, if I draw a line here, thanks for the vote. I think you're a little premature, but of course, looking at an angle, and you might have thought the chalk was all the way over here. That's probably what it was, because the person raised the hand is a pretty big angle. That looks like x equals 2 to me. Okay, because it's right at about halfway between 0 and -4, or x equals -2. So I can go ahead and label that. We don't want to label too many of these things because then things get real cluttered up and you can't tell what's what. Okay. Now you can reason out that -3 is halfway between -2 and -4, isn't it? So I'll label that one up here just because things are getting a little cluttered down here. Okay, and I'll even make a little arrow and show which line it is. And if you want, you could label x equals -3 here with your color. Okay, so now we've got the line x equals -3. We're on our way defining where y equals 9, right? Now, is 9 closer to 0 or 16? Tell me, closer to 0 or closer to 16? Okay, so far all the votes are thumbs up. It is closer to 16 because what's halfway between 0 and 16? Show me with your fingers. 8. Okay. Now I asked that because I get people in pre-calculus can't answer those questions. Sometimes they even pass if they work very, very hard. But usually somebody who can't answer those questions isn't prepared to think through pre-calculus. Okay. So let's just kind of get the halfway. Let's go halfway here. That'd be maybe about here. say y equals 8 about here. And then 9 is a lot closer to 8 than it is to 16. So I'm just going to draw a line here and hope that that's a good representation of y equals 9. Then where the x equals -3 line crosses the y equals 9 line, I make a mark. Okay, well, let's not worry about 1/2 or 2/3 until we worry about 1 and 2. Okay. Can we do the x equals 2 line and the y equals 4 line? If you get that, then you might do the 1/1 line. Then you can mess with the fractions a little bit if you want to. But let's start with that first row on the table where x equals 2 and y equals 4. Okay, so halfway between, and we get the x equals 2 line. Okay. And what's the y value? It's 4. Now, where is y equals 4? Well, we labeled y equals 8. That's half of 16. So that should be midway between the y equals 16 line and the y equals 0 line, which is the x-axis. So to get y equals 4, we go halfway between the y equals 8 line and the y equals 0 line, and that's going to put us right about here. And we know that when x equals 2, y equals 4. So we get this point. Then what do we have? We have x equals 1 and y equals 1. X equals 1 is halfway between x equals 0 and x equals 2. I'll label that up here. And y equals 1. Well, y equals 2 is halfway between y equals 0 and y equals 4. That would be here. Halfway between y equals 0 and y equals 2 would be y equals 1, which would be down about here. So 4 times this distance would be this distance. I think I have it just a little bit high. But it's okay. We'll put an X here. Or some kind of a mark, a dot, an X. I will observe that when x equals 0, y equals 0, because 0 squared is 0. So I'm going to take the privilege of putting a point here. Okay. Now, if you draw a big enough graph, you can still do x equals 1/2, y equals 1/4. Where's that going to be? Now, this is pretty important for understanding the shape of the graph. Otherwise, shape of your graph might be a little pointy. But it's very smooth when it gets down here. So x equals 1/2, and I'm going to make that a little different color. So there's x equals 1/2, halfway between 0 and 1. Okay. Where's x equals 1/4? Well, it's 4 times as close to the x-axis as this line. Okay. So it's way down here, real close to the x-axis. So we get a point about here. Now, if we want to draw a smooth curve from here up to here or from here down to here, turns out that it's got to start out completely flat. Right at this point, it's flat. It's not pointing. So it starts out parallel to the x-axis and then starts curving upward and does this. Okay. And that's why I include this 0.1/2, 1/4. So you see how the thing flattens out at the origin. Okay. Then we notice that if x was 3, y would have to be 9. Just like -3 gives you 9, 3 would certainly give you 9, which would give us a point about here. So, I should have, my curve should have been a little further this way. Should have included the 0.39, but I kind of missed it. If I'd have had that point, I'd have probably drawn a better curve. But right now, we're just learning how to manipulate tables and get graphs. So on this side, it's going to look just like it does on this side. Okay, so it's going to do this. I kind of screwed up, but there it is. It's hard to get it just right down here. But it flattens out just for an instant when it hits the x-axis. We say the graph is tangent to the x-axis. If you have this thing upside down like this, then you could balance a stick right on the top of it. Okay, it's sort of image of tangent. Okay. Let's do another one. Now, values that we're going to use for x are -2, -1, 0, 1, and 2. Now, I recommend that you start at the bottom and work up, because the rules are easier. Rules get harder as you move up, so it's good to have your handle on at least one calculation, okay? So what are we going to get when y equals 2? When x equals 2, y equals 2 to the x. So you would get 2 to the second. It's 2 times 2, which is 4. So it should be clear that you're going to get 4 if x equals 2. Okay? Now show me the calculations for the other 4. I could have been really clear about making the precaution of writing y equals 2 to the x, so you know what function you're using, right? So there can be a tendency to just start doing calculations without having this to look at. You need to have this to look at. Okay, so make sure that's written out there so you know what the graph represents. Okay, now this is always a problem for people in pre-calculus or in this course or any other. Okay, and what it comes down to is you're not remembering the rules of exponents. You're not applying them. Okay, so 2 to the second means 2 times 2. Just put in context. 2 to the third means 2 times 2 times 2. 2 to the fourth means 2 times 2 times 2 times 2. So if x equals 1, you replace this x with a 1. So you get 2 to the 1. And what's that? Well, if 2 to the fourth means you multiply 2 4 times, if 2 to the third means you got 3 of them, 2 to the second means you got 2 of them, then 2 to the first means you just got 1 of them. So that's going to be 2. Any number to the first power is itself. But that's just because of what the powers mean. And you want to think of like this, make sure you put that in context. And here's where confusion starts. People want to say 2 to the 0 is 0, even though one of the rules of exponents says any number to the 0 power is 1. That is a rule of exponents that has slipped by everybody that I looked at. I didn't look at everybody's paper, okay, on that one. And I should put that out here, 2 to the 0 equals 1 exponent says that a to the 0 equals 1 for any a. Okay? Anybody remember what a to the negative 1 is? Guess at that? Don't see a whole lot of light of recognition in your eyes, but maybe you're doing a good job of hiding it. Okay? It means 1 over a. A to the negative n equals 1 over a to the n. And this is so because if you multiply a to the negative n by a to the n, you're going to add exponents, you're going to get a to the 0. Well, if you multiply 1 over a to the n by a to the n, you get 1. Okay? So I've said that quickly, I'm not going to belabor it right now. That's the rule. And you absolutely have to remember that rule. Half a pre-calculus will be incomprehensible to you if you don't remember that rule. So, well, first of all, I didn't write my 1 here. 2 to the negative 1 equals 1 over 2 to the 1, which is 1 over 2. So we get 1/2. And 2 to the negative 2 equals 1 over 2 squared equals 1/4. So we get 1/4. So it's not totally hard to remember that rule. You got to make note of it. You got to be sure from here on, you know that a to the 0 is always 1. Any number to the 0 is 1. And that any number to a negative exponent is the reciprocal of the number, that power. Okay? I didn't say that exactly right, but that's kind of the way it feels. And I'll leave it at that for now. Okay, so I want to sketch a graph of this. Now my x values go from -2 to 2. So I'm going to put x equals -2 over here. And x equals 2 over here. Halfway between is my y-axis, which is of course where x equals 0. Okay. Then halfway between, this is -2, halfway between -2 and 0 is about here. So I draw a vertical line. Here we'll call this x equals -1. And then halfway between 0 and 2, we draw a line. And we call that x equals 1. Okay? So now we've got lines for every value of x. We've also got a scale. I don't particularly like writing the scale right next to the axis because a lot of times then you do a graph and it goes right through your labels. Okay? So I'm moving the labels away from the x-axis so we can get a neater graph. And same thing for the y-axis. Now, the y values go from 1/4 up to 4. The biggest value is 4. So I'm going to draw y equals 4 line up here. Then, instead of trying to do y equals 1, 2, 3, and 4, it's easy to cut 4 in half, to go halfway between here and here, and draw the line y equals 2. And then I can go halfway between y equals 2 and y equals 0, which is the x-axis, which I should label y equals 0. Here's y equals 1. Okay. Now I've got all the lines I need in order to represent these 3 points. X is 0, y is 1. Well, here's the x equals 0 line, and here's the y equals 1 line. They meet right here. So that's a point on my graph. I could even label that point. A little dangerous to label your points until you know where your curve is going to be. But I know where the curve is going to be, so I'm going to go ahead and label it. I label it here, it's going to be pretty well out of the way. Okay. Then we have x equals 1, y equals 2. Here's x equals 1. Here's y equals 2. Where do they meet? They meet here. And we could label that point 0, 2, 1, 2, sorry. Then we have the point where x is 2 and y is 4. Well, here's x equals 2. Here's y equals 4. And here's our point. Okay. So that's 3 points on the graph. Now let's look at a pattern here. Going from this point to this point, I move left 1 unit and I cut my value from 4 to 2. It means I cut the value in half, right? In other words, I move 1 unit to the left and I go halfway down to the x-axis. Then if I go from this point to this point, I can go 1 point left and halfway to the x-axis, which tells me if this pattern continues, if I go 1 point left or 1 line left and halfway to the x-axis, I should be about here. And then if I go 1 left and halfway to the x-axis, that'll put me about here, which gets in the way of my labeling for y equals 0. So that's maybe where my points are going to be if the pattern holds. The other pattern is if we go from 2 to the 1 to 2 to the second, 2 to the third to 2 to the fourth, we have 1, 2, then we have a couple of them, then we have 3, and then we have 4 of them, right? Which means that each of these is 2 times the one before it. 2 cubed is 2 times 2 times 2. If I double that, I multiply it by 2. I get 2 times 2 times 2 times 2. Okay? If I go from 2 times 2 times 2 to 2 times 2 times, to just 2 times 2, it goes to half. This is half of this because this is twice this. Every additional 2 I multiply by doubles the number. If you understand that, that could be useful. It's a good thing to understand and think about. If you don't, it's not going to be in the test. But if you do, it can be very useful when you're trying to learn the behavior function. Okay. So this aside, let's see if this works. Okay. We would want the line for x equals -1. Well, we have it. We want the line for y equals 1/2. Where's that line? It's halfway between y equals 1 and y equals 0. That's totally consistent with the way I located this point. I moved 1 line left and I moved twice as close to the x-axis, meaning I went from y equals 1 to y equals 1/2. If I then move twice as close again to the x-axis, and if you don't have a pretty big graph, it's a little hard to do this. Well, how could it be on the x-axis? Okay. Another thing about this that's worth storing away. If I keep moving 1 unit to the left and twice as close to the x-axis, am I ever going to get to the x-axis? Well, see that stack of boxes there? I'm going to move halfway. Now I'm going to move halfway again. Am I there yet? I'm not close, but I'm not there, right? Now move halfway. Am I there yet? Now move halfway again. I keep moving halfway. Am I ever going to get there? No, because I've always got some distance to go. And I can always go twice as close. Now, physically, I can't. After 10 steps, I'll be so close to it that, well, after 20 steps, I'll be so close to it that the thermal vibrations in my boots and in the box will make the two keep bumping into each other because they aren't really fixed points. Okay. So, yeah, in practical purposes, eventually anything's going to touch, at least sporadically. Okay. But in theoretical purposes, as long as you got some distance to go, you're going to be able to go halfway without getting. Okay. And you always have some distance to go. It's kind of a mathematical induction argument, but don't even worry about that. Okay, do we understand how this graph can be constructed? Do you understand then that all we need is a line here, a line twice as close, a line twice as close, a line twice as close, and a line twice as close to the x-axis? 5 lines. Okay. And you don't need to label x equals 3 if y equals 3. If you want y equals 3, you can draw it halfway between 2 and 4. If you want y equals 2.5, well, you figure that out. Okay. Now we can sketch a graph. Graphs you'll ever, it is probably the smoothest graph in existence. Okay. There are other graphs that are equally smooth, but none of them have a simple formula like this. Okay. It has a lot of really important, fascinating characteristics. And you learn about those in calculus. First, you got to get through pre-calculus. We construct these graphs, move them around, make them do things. Now, one good thing about this graph, if you change the label on y, let's say instead y equals 1 stands for y equals 1,000. $1,000. Okay. Then if you move from here to here, it doubles. If you move 1 unit to the right, it doubles. If you move another unit to the right, it doubles. So after 2 steps to the right, you've got $4,000. Now at current interest rates, it takes between 15 and 20 years to double your money. So this might be, instead of 1, this might be 15 years. That might be T for time. This might be 15 years, this might be 30 years. If you do a good graph, you can predict what you'll have after 7 years, okay? Or after 11 years. Now, you can also do it with your calculator, but you can just draw this graph, and if you do a good freehand graph, you can come up with a pretty good estimate, okay? This is called an exponential function. That's your squaring function or quadratic. There's one more that we want to take at least a brief look at. And I'm not going to have you do all the details. We've got about 9 minutes left. But I am going to give you a couple of minutes to see. Okay, this is y equals 1 over x. I'm gonna give you about 3 minutes to see if you can make a table. You notice I don't have zero here. Can't do 1/0. You can't divide by zero. It does not exist. It's not defined. If you think it is, tell me how long it's going to take to count to 1 by zeros. How many zeros does it take to make 1? You count by zeros, you always have 0, okay? No matter how many zeros you have, you're not going to get 1, so you can't divide 1 by 0. See if you can write out the rules for the calculation. And the result. I can only give you a couple of minutes on this, so you might not get very far. See how far you can get. Okay. Now, gotta be careful with this. And some people did pretty well on this. And some people made some mistakes. Or didn't quite know what to do. And that's exactly what I always see. So we start with these functions in pre-calculus. It's the first thing we do. Okay. And we don't want to be stumbling over the arithmetic. But everybody spends 2 weeks stumbling over 5th grade arithmetic. And it's maybe middle school arithmetic, okay? Because they teach you the arithmetic and then they put a calculator in your hand and you have to do arithmetic again, okay? That's basically where the problem lies. Okay, so whether I'm right or wrong about that, let's go on. Okay, so y equals 1/x. This means if x equals -2, you better write 1/-2. What's that equal? Well, that's the same as -1/2, right? So you're going to get -1/2. And put that in parentheses to make sure we don't confuse that. Then what's 1/-1? Well, 1 divided by 1 is 1. If you divide by a negative, you're going to get a negative. You're going to get -1. Okay? Now, what's 1/-1/2? You're dividing by a fraction. That means you multiply by the reciprocal. It's 1 times -2/1, which is -2. 1/1/2 is 1 times 2/1, which is 2. Okay. Then 1/1 equals 1. So here you get 1. And 1/2 is 1/2. There's our table. Now, my x values go from -2 to 2. So I'm going to open a window between x equals -2 and x equals 2. My y values go from -2 to 2, right? Biggest negative y value is -2. The biggest positive y value is 2. So I've got to go from y equals -2 to y equals 2. Which means then that halfway here is x equals 0. Well, x equals 0 is my y-axis. So I do this. Halfway between here and here is y equals 0. So I might have, it's x equals 0. Is y equals 0. I don't know what I'm doing. Okay, so here's my y-axis. I got into the loop and I went one time around the loop too far. Whatever, I screwed up. Okay, makes sense? Now I have these values of y and these values of x. I also need ones and one halves, negative ones and negative one halves. So right here is y equals negative one. Right here is y equals negative one half. And up here is y equals one. And here is y equals one half. And then I've got x equals negative one. Not doing this very accurately. And x equals negative one half. And x equals one. And x equals one half. Now I can plot my points. Negative two, negative one half. Uh-oh. Oh, man. See what I did there? That wasn't going to work. Y equals negative one half is here. And okay. Got carried away, moving downward. Okay, so when x equals negative two, y equals negative one half. There it is. When x equals one, y equals negative. When x equals negative one, y equals negative one. When x equals negative one half, y equals negative two. Got all my points there. I don't have any extraneous lines in here. I just want to get the shape of the graph. And you can check for yourself that these 3 points are on the graph. Okay? So I can draw a curve from here to here. And I can draw a curve. I can't join this point to this point. Why? Because if I do, I'm going to have a y value when x equals 0. Wherever I draw, if I draw the line here and it goes through the x-axis here, that tells me that 1 over 0 is 0.86. No, it's undefined. We can't cross the y-axis. Now, what this graph actually does, if you look at it beyond this table, it keeps getting closer and closer to the y-axis up here, never touches it. Keeps getting closer to the x-axis over here, never touches it. Kind of the way the exponential function is, you move to the left, never gives you y equals 0, it never touches the x-axis, okay? And similar over here. Call these asymptotes. And it's maybe a good word to look at. Not sure you're going to see it in this written math assignment, but there it is. Okay, now I'd intended to also cover function notation today, but this is really important. We'll touch on function notation. I'll rearrange the assignments a little bit. Okay, fair enough. This function notation is a big stumbling block for people, but it's something I want you to see so you know where you're headed. Okay, it's also a standard intermediate algebra topic.